Welcome in this tutorial video on EEGpal. We are going to see how works the statistics model which permits to perform statistics on track. When you want to explore the difference inside of your dataset, you can make a statistical analysis over your tracks. It corresponds to make a test for each time point and each electrode you specified. It is done in two phases. In the first, you will need to specify the experimental factor and condition using the full design windows. And secondly, you will configure the test to perform using the statistics model. This one will permit to perform one of those statistical tests depending of your input data. You can perform a one sample t-test when you specify only one condition. You can perform a paired t-test when you specify one within subject factor. You can perform a two sample t-test when you specify one between subject factor. But it can also perform ANOVA with repeated measures when you specify only within subject factor, ANOVA between when you specified between subject factor, as well as ANOVA mixed when you specified within and between subject factors in the same model. Warning: the use of the statistics model will require the statistics and machine learning package. It is a commercial toolbox for MATLAB sold by MathWorks. Let's see a practical example. We are going to compare the ever-correlated potential during a phase or car perception between two experimental populations, patients and controls. It corresponds to perform a ANOVA mixed 2 by 2 with one between subject factor, which is the experimental population, and one within subject factor, which are the condition. Let's import the data file. All files are required to have the same number of channels, sampling rate, as well as duration. We need to specify now for each file the subject, condition, and factor level. We will do that using the full design windows. Here you can specify a name for your design. Then EEGpal will need to know which file corresponds to which participant. You need to name your file in order to have a substring which permit to identify the participant. So you see here that the three first characters correspond to the participant code. So I put the subject code for the first file, and EEGpal will interpret which participant corresponds to which file. Now we need to specify the number of factors of our design, which is 2, and the number of conditions. As we got a design 2 by 2, we will have 4 conditions. Now you are going to specify the condition name. You cannot pick any name, in fact. Just as for the subject identification, you have to specify the substring in the file name which permits to identify each condition. Now you see that my condition column is filled with the substring which permits to identify each condition. Now I can give a name to my factor by entering it here. Then I need to manually specify the level for each of my factors. So for my factor population, the two first are the patients. So I put 1, 1, 2, 2. And for condition level, I will have the phase 1, 2 for the course, then 1, phase 2 course. Now my design matrix is specified. I need to specify if I got a between factor. By default, all the factors are considered as within. As my first factor is between, I will tick this option in order that EEGpal know that the first factor has to be considered as between. Now that my design is specified, I can press on the Save button. You see now that EEGpal has automatically filled the column to identify the subject, the condition, as well as the factor level. Now we are ready to open the statistic model. The right column of the windows is working in the same way as the peak export that we have seen in a previous video. So first you have to specify the sampling rate in your files. Then you can specify your time interval of interest, either in millisecond or in time frame. Take account that the 0 is always the beginning of the file. In our example, we are interested to make statistic between the presentation of the stimulation, which is 100 milliseconds after the start file, until the end of the file. So this button. You have a supplementary option here if you would like to average all time points in this interval. Then it will perform the stat only on this average and not on individual time points. Then you can specify on which channel you would like to perform the test. So in our case, we are interested by the electrode 28. And you can also perform the statistic on the average of the specified channel or on the GFP and the dissimilarity. The middle column will permit you to parameter your statistical test. At the top, it reminds you the design that you have specified in the full model windows. We got our two factors and two levels. Then you can choose which statistic you want to perform. The option of this drop-down menu will depend on the design you specified. Then you can specify the p-value threshold, and then you can specify if you want to perform a correction for multiple comparison. It is quite recommended because you are going to do a lot of tests, especially if you do a test over all time range. You can use the FDR for the false discovery rate correction using the algorithm from this paper. You can consult the FAQ from the help manual to get more detail. You can add a supplementary threshold on the minimal cluster size, mean the number of electrodes which are significant at the same time, or on the duration. It means that the significant period should have a minimal duration of 10 time frames, for example. Then for the output, you can choose the output format between those EEG file formats. The RIS is for the inverse solution format of CarTool or directly in CSV file. Then you specify the output folder and you can add an optional string suffix to the results file. And I can run. If we look inside of the output folder, we see that EEGpal has generated 6 files, 3 files for the F values and 3 files for the P values. And for each of them, we got 1 file with the main effect of the factor population, 1 file for the cognition factor, and 1 file for the interaction. The interesting files are the P values. If I open it in CarTool, it will display only the p-value which are significant. So everything which is in gray is non-significant, and when you have a yellow-red color is that there was a significant period. We see here we have our three channels, so the POA channel as well as the GFP and the dissimilarity, and it permits to see that we have a significant effect on the experimental population between 48 to 69 milliseconds. If we open an F file, you will have trace which represents not the amplitude but the F value for every test and every time point. For more details, don't forget to press on the help button to get the tutorial PDF. This concludes this video, and for the next one we are going to see the frequencying model.